Hello, and welcome to episode 1 of Project Goliath. In this episode, we are looking at initial designs for the mech and establishing workflows. If you haven't watched the prologue for Project Goliath, I will put a link to it here. In that video, I discussed how I want the controls to be easy to learn and hard to master. In this episode, we are going to start off working with servos. I am testing different input configurations with joysticks to get a better sense of how I want the controls to function. The initial testing of one stick versus two sticks to do one operation is to come to grips with the designing of a control input system. The goal for this mech is to have a human pilot. Humans generally have 2 hands and 2 feet. Initially, let's think of common human to machine input systems. A car, for example, is 2 hands on the wheel and 1 foot responsible for 2 pedals, unless it has a clutch, of course, and or you like left foot braking. In an excavator, there are multiple levers, pedals, etc., and it is more complicated than a car. The control scheme I am looking for is between a car and heavy machinery. Each extremity responsible for one input. Feet for throttle and braking with pedals, and the hands control joysticks for direction input, and probably some other input system that is not part of the design yet. It may need to be tank controls, however, this will eventually be determined once the design of the mech matures. The design I am working towards will probably lend itself better to some other method. I will discuss later in the video how I want to achieve a platform from which quick iteration can be achieved. I do not view this vehicle as a robot, but more of an industrial vehicle like a skid steer. It will probably also share some design characteristics with a skid steer. Moving on to designing the first leg, I have cardboard standing in as the leg pieces. Here I'm getting an understanding of how the servos move in relation to each other in a set sequence. I am also still working out the 2 versus 1 joystick inputs. You can see me holding the Arduino board on the table because I almost had to go flying off the table a bit earlier. We'll solve this issue later. This is the old, just temporary leg for, see, it just comes right off. It's for just basically getting an idea of how the servos move in relation to each other. Now we have these parts that I designed. These leg pieces were designed with basic 9-gram servos in mind, and that slot right there will fit the basic cross section of the servo attachment, and you just slot it in there, and it's an easy attach system. It's not very accurate. It's not level or plumb or square or anything like that. It's just a basic design to get more than just a cardboard prototype going. Here I'm attaching the other servo to the other side, which is designed where the little tabs just slot in, and then you can drill them like this, pre-drill for your screws. I don't know, probably just screwing them in will be just fine, but I wanted to pre-drill just in case. The infill on this is like 20% on the printed part, and so I was trying to be careful not to strip it out entirely, and it will hold there if you're not pulling on it too hard. 3 motors hooked into these little leg pieces. This one is supposed to be the foot, but I haven't designed a foot piece yet, so I'm just going to use this other one I printed. These are in high-speed PLA plus, and this is in tough PLA. And so we're just going to put that one on there, and that will give me just a foot. Thankfully they're different colors, so it's easy to tell. This is the first foot I printed. It is, well, not necessarily solid, but it's, got infill, but it is way too big. So I redesigned and reprinted this little guy. Much better size, reduced the weight. The servos were having a little bit of trouble with this guy. The way I designed this, it can have a little bit of play to it. So it's a little bit compliant. That's barely at all though. And my thought was later on I could design something like this where there would be, I guess, an internal suspension system for the foot rather than having external things going on. But that's much farther in the future. And for now, that's the current foot. So this is the main housing of the PLS, or the prototype leg system. This is where all your electronics will go, and eventually a human, but obviously not in one this small. There will be a lot more refinement, and of course it's going to be much bigger. But the idea is that you attach your legs on either side up here so that the center of gravity is lower, so if it falls over, it's not as bad. And so with this system, everything is contained in this one box, and you just attach different legs as you iterate. This is the unit assembled. The tolerances on everything are very loose, and the 3D printing doesn't exactly make accuracy for something like this. There's a lot of slop in it. This is the basic shape and idea. The idea is for it to be like this and move. Ignore the joysticks for now, but the basic idea is it's like this, and these move however they need to move. So I ended up with this, and the design is not perfect. There are a lot of issues with it. It helped me establish some workflows, but I like the idea of having a central box or body or compartment that will house the electronics, and then the only thing to iterate on are the legs. And so the main housing will have everything I need, and I can just switch legs out and work through iterating the legs. But using these servos, I really have no need to continue to chase that, and I will instead be upgrading to these stepper motors and actually working out inverse kinematics and everything like that. That will require a whole new design, but I've already established the workflows, so it'll go a lot faster. Thank you so much for watching to the end of this video, and I hope you stick around to watch this project evolve. In the future, there'll be more videos on the PLS and the actual mech itself, as well as the sub-objectives like the helmet and the pilot identification system. If you want videos on the MRL, check out the Mecha Racing League channel. I'll have a link in the description below. Thank you so much for watching, and bye for now.